Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today I am going to explain about single phase half wave uncontrolled rectifier in that RE and RLE type of load. So here there are different types of rectifiers. Rectifier is a DC to DC converter which converts from variable DC to the AC to DC converter, which converts from variable AC to the fixed DC. So here different types of rectifiers, single phase and three phase, and in the single phase half wave and full wave, and the three phase also half wave and full wave, and in this uncontrolled and controlled, controlled and semi controlled under the category of full wave rectifier. So in the last two lectures, in one lecture, single phase half wave uncontrolled rectifier with R load, and next in in single phase half wave uncontrolled rectifier with RL and RL with freewheeling diode we discussed. So today I am going to explain about RE and RLE type of load. I am going to explain in this lecture. So now here this is a circuit diagram for single phase half wave uncontrolled rectifier with RE type of load. This is the resistor and this is the capacitor. So battery type load. So this is, so here is the output voltage. Supply voltage is I am giving Vs equals to Vm sin omega t. Now here what Vm supply voltage I am giving to this diode, and now here we will get the load is a RE type of load. RE type of load. So here V equals to Vm sin omega t. So here this is a V maximum value. So now here what will happen? So I am dividing this here up to 2 pi. This is a pi, and here is a pi minus theta, and here is a theta only. So it is not required. And now here this is 0. And now here, so I will divide this one here. The angle is, so first one, so pi to 0 to 2 pi I am dividing different parts. First one is a 0 to theta, first range, and this range 0 to theta, and next theta to pi minus theta, theta to pi minus theta, next pi minus theta to pi, and next pi to 2 pi. Let me change the color over here. So this is 1 and this is 1. So 0 to theta, and theta to pi minus theta, and pi minus theta to pi, and next here pi to 2 pi. So here 4 categories. So how diode will acts, that I will explain. So from 0 to theta, so this is the battery voltage is E. This is the battery voltage E. So now here this is a supply voltage V. So now here 0 to theta, so this is a Vs. So now here this is E. So now here in this case, so that I am going to explain. So first here 4 parts I am dividing. First one, so Vs is less than the E in this case. This Vs is less than E. And next case, Vs is greater than E. In this case, pi to 2 pi. So E is less than Vs. So this is the case. And next case, pi to pi minus theta to pi. So this is Vs is less than the E. V is greater than. So here in this range, this is E and this is the Vs. And next here in this case, so Vs is less than 0. That means less than E. So this is the first case. And let me change the color over here. Next. Now here Vs is less than E means the output voltage V naught equals to E only. So now here this output voltage equals to E only. This output voltage equals to up to theta. So this output voltage is E only. But here, so V naught equals to Vs. So output voltage equals to V naught equals to Vs only. V naught equals to Vs only. So now here in this case V naught equals to E only. So now here this is in this case V naught equals to E only. Now here in this case, so V naught equals to E only in this case also. Pi to pi minus theta, this is a pi and this is a 2 pi. So now here, let me change the color over here. So the diode is in reverse bias. So the diode is in reverse bias means here this is a V naught. This is that equals to E means this is the Vs. So Vs is less than E means here anode voltage. Anode voltage is less than the cathode voltage, that is the diode is in reverse bias. But here in this case diode is in forward bias because Vs is greater than E. Anode voltage is greater than the cathode voltage. And now here the diode is in reverse bias, same as in pi minus theta to pi. And here is the diode is in reverse bias. Now next case. Next. What about the current? So I naught equals to 0 only. So this voltage is E and now here this current is 0 and this current is also 0 and this current is also 0 and this current equals to this V. Actually V naught equals to I naught into R plus E. So if you apply KVL in this loop, and now here I naught equals to V naught minus E by R. Vs minus Vs into I V that is Vs. V naught means that is Vs. So Vs minus E by R. So now here, so this is the case, and here is the current is 0 and here is also current is 0. And next case here, this is up to here, this current is here and this cycle completes. And now here this is the case. And now here what about the diode? What about the diode voltage? What about the diode voltage? Vd is equals to Vs minus E. Vd equals to Vs minus E. So here this is a Vs minus E means here. So it starts from here only. So Vd minus E. So this is minus E. And next here, this is the case, it will be So VD minus E, and it is short circuited. And now next case here, it will be, sorry, here. So now here this peak inverse voltage equals to, so minus, this is minus, so Vm, this is negative Vm plus E only. So now here this is a VD equals to Vs minus E, and this voltage is 0. VD is short circuited because it is in forward bias. This VD equals 0. So VD equals to Vs minus E. So this configuration we are using from 0 to theta, so that Vs is less than the E, and we from theta to pi, so the Vs is greater than E, and next to theta pi minus theta to pi, so Vs is less than E, and this up to here, this is a Vs minus E. So this is E naught, E only. So now here in this case diode is in reverse bias, forward bias, reverse bias, and here reverse bias. So this is the output current, and this is the diode voltage. So now here what will be the output? First question is conduction angle of diode is. Conduction angle of diode means here it is conducting up to, so this is a theta, and this is a pi minus theta, this is a pi, and this is 0. So conduction angle of diode means pi minus, it is conducting up to, in this range only it will conduct. So pi minus theta to minus theta. In this duration only the diode is in forward bias. So now here in this case, so now here pi minus 2 theta. And what about the peak inverse voltage? Peak inverse voltage. So now here second question is peak inverse voltage equals to Vm plus E. So now third question is the average value. V naught average value is equals to, so here 1 by 2 pi 0 to pi Vm sin omega t. But here Vm sin omega t, so actual this equation in the previous, but here this 1 by 2 pi. So now here this output voltage is 0 to theta, so that value is E d omega t plus theta to pi minus theta Vm sin omega t. So this is the supply voltage, sin omega t plus pi minus theta to up to 2 pi, this value is d omega t. So this is the average value. And now here what about the RMS value? V naught, I naught, fourth one is a I naught RMS equals to, so that equals to Vs minus V naught average minus E by R. So now here in this same way for the RMS value, so that equals to V naught RMS equals to 1 by 2 pi under root, so that equals to 1 by 2 pi under root 0 to theta E d omega t plus 0 theta to pi minus theta, so Vm sin omega t plus theta to pi minus theta, so that is E d omega t. So this is square, so this is square d omega t, and this is E square. So this is the case for V not RMS square. And now here next, so this is the RLE type of load. Now next case is a RLE type of load. In the RLE type of load, same diagram. So it is conducting, so this is the E only, E only. So this E, R, L and E. So now here in this case, so now in this case, what will happen? Same circuit. This is the actual diagram for RE type of load. So now here this is the case. This is RE type of load. And now here this is the case. But what will happen because of this inductor stores the energy in the form of magnetic field, and that stored energy, when it is in reverse bias, so it will sends the power from the load to the source because of the inductive property. So let me change the color over here. So first here, because of the inductive property, so it is conducting up to beta. It is conducting up to beta. So this is up to this beta only. So now here this output voltage, it is short circuited up to beta. Up to beta. So this is the case. Next here is also. So in the next slide I will explain, I will clearly. So this is the case. So this is E. So it is conducting up to beta. Up to beta. Here is again theta, sorry, 0, 0, theta, pi minus theta. Here is a pi, here is a beta, and here again 2 pi plus theta. And now here it is conducting 2 pi minus 2 theta, 2 pi plus theta, 3 pi minus theta, here up to 3 pi, and next here is a 3 pi beta. And now here, what about the current is conducting up to beta. So now here is current is conducting up to beta. So in the previous lecture, in the previous RE type of load, the maximum value is pi by 2, but it is in between beta to pi by 2, the maximum value of current. This is beta and this is a theta in between 0 to. In the previous case, that value is pi by 2. And now here I am drawing the output voltage, diode voltage. Diode voltage, it is conducting up to here. And now here, this is the case. Here is the case. So now here the average output voltage V0 average equals to, so now here 1 by 2 pi integral of 0 to theta, that is E d omega t, plus theta to beta, so that value is Vm sin omega t, and next plus beta to 2 pi, that value is E d omega t. Same way for RMS value, V0 RMS equals to, so 1 by 2 pi under root 0 to theta, so E square d omega t, plus theta to pi beta, so Vm sin omega t whole square d omega t, plus beta to 2 pi, so that is E square d omega t. So V0 RMS and V naught average value. And what about the maximum value is in between pi by 2 to beta. So that maximum value of current. And next thing here, that max peak inverse voltage is here Vm plus E only. So that is, and next another question is conduction angle. Gamma of D equals to, so gamma of D beta minus theta. So these are the cases. I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share, and subscribe. Hit the bell icon for more updates.